Good morning, everybody. If you're watching this video, you're trying to get some insight as to how to solve quadratics with graphing and how to solve quadratics with factoring. Now, we did this lesson on Thursday in some classes, but most classes saw this on Friday, the 30th of May. So if you're listening in, let me do the best I can to get you through this rather quickly and so that you're prepared to move on. Now, the first thing that we talked about when we looked at this was how to solve by graphing when we had a regular equation. Now, the equation that we're talking about is this guy right here that's highlighted in purple. Now, what you'll notice is when we graph this, on the left-hand side I have an image of it graphed. When we graphed it, it was a regular parabola that simply had been shifted down 9 spaces, and that's why the minus 9 is there. But you'll also notice that I have these red arrows indicating the spot on the right and the spot on the left. Now, what we're going to be doing is looking for this thing called an x-intercept. We're going to look for where the parabola crosses the x-axis. And of course, if this right here is your x-axis, we're going to look for those 2 points where the parabola touches. Now, to try and do that with some graphing, you can type in y equals and then hit graph and type in your x squared minus 9. What we're going to do is show it a slightly different way. We're going to show that the y value becomes 0 because on this graph to the left, everywhere where y equals 0 is on this line. And what we're trying to do is we're trying to find out where and what the x will be when y equals 0. So instead of y equals, I'm going to put 0 equals. And you'll notice that whether we put the 0 on the left or whether we put the 0 on the right, ultimately I simply have a quadratic equation equal to 0, and that's what I'm after. Now when that happens, all you really need to do is type this into your graphing calculator. The screen's going to pop up. You're going to look at where the parabola crosses the x-axis, which is here and here, and you're going to write down the two answers, the two solutions. So the first solution is x equals not 1, not 2, but 3. So x equals 3. And the other answer will be not 1, not 2, but, and I missed it a little bit, x is negative 3. So there's your negative 3. And you can write it two different ways, 1 or 2. So many parabolas and many equations are going to look like this. Now, sometimes you're going to have parabolas that only cross at one point. For example, if I graphed negative 1/3 x squared equals y, or in this case equals 0, because I swapped out the y and the 0, what I would find is that I only have the parabola touching at exactly one spot. And in this particular case, that one spot is the origin. It has only one solution, and that solution is the x value must equal 0. In other words, if I put 0 into this equation, it would work. But that's the only number that's going to make that equation work. That's what I mean by a solution. Now, it's also possible, if we're looking at graphing, that the graph itself does not touch the x-axis at all. If it does not touch the x-axis, it has no zeros, or it has no solution. Now, that's very different than not having ordered pairs that match up with those 5 black dots that you see. For example, this black dot here is 1, 3. That's a solution to x squared plus 2 equals y, which is what you're using to graph, or this one here, which is 2 and looks like 5, 3, 6, or this one, which is 0, 2, and so on. Those 3 examples, and the ones that are on the opposite side as well, those 3 examples are solutions to the original quadratic equation. You'll notice that we've modified our equation. We've taken out the y value, and we've replaced that y value with the 0, because what we're after is a very particular type of solution, one that crosses the x-axis. And in this case, there isn't one, so there's no solution. So if we were to go back to the first slide, I would say to solve by graphing, you either graph by hand on a piece of graph paper, or you use a graphing calculator or some app that you might have available to you, and you look for where the parabola touches the x-axis and whether it touches. Sorry, we had a minor technical difficulty there, so I'm unable to go back and look at previous slides, but what I was going to do is show you those first couple slides where you would see 2 solutions, 1 solution, or in this case, 0 solutions. Now, the second part of this is a little bit more work. Try to do the best I can to explain it. And in class, we started with this problem right here. And I asked if I had 2 things that were being multiplied, one and another, and I knew the solution had to be 0, then what would I know about these 2 items? Now, many students were telling me that what they would know is that the first item or the second item, one of those two had to be 0. Because any number times 0 equals 0, so one of these two things has to equal 0. A few other students told me, well, they both could equal 0, and they're right about that as well. And we're going to use that fact, what's called the multiplicative property of 0. And we're going to go ahead and work with stuff like it. Now, instead of an unknown value and an unknown value, we're going to make it a little bit more algebraic. We're going to make it look like x and x plus 1. Still two things I don't know, but what I'm going to try to ask you, and what you should ask yourself is, how do I come up with a value that turns this thing into 0? And what you're going to do is you're going to take the first value and you're going to set it equal to 0, and if we get lucky, x equals 0 is one of the answers. If we don't get lucky when we set it equal to 0, we just do a little bit of math work, and we come out with, I'm out of space, x is -1. And you get two solutions, or two x-intercepts, or two zeros if you prefer. And you can write it like I have it circled, or you can write it all together, 0, -1. That would be a correct solution to this as well. Now, if the problem gets a little bit more complex, you still just have the first one has to be 0, or the second one has to be 0. -1 to this, -2 to this, and again I'm out of space, so I'm going to put it off to the right hand side. X would equal -1, or you could imagine x could also have equaled -2. Now, if the problem gets more complex like the one at the bottom, the concept is, however, still the same. I'm going to take your 2x plus 1 and I'm going to set it equal to 0. I'm going to take the x minus 10 and set it equal to 0. And other than the algebra being just a tiny bit harder, 2x plus 1 is 0, so -1 means 2x is -1. I'm going to divide both sides by 2. I'm really out of space here. So one of my answers is going to be x is -1/2. And the other answer, x minus 10 is 0. I'm going to add 10 to both sides. And I'm going to get x is 10. And now, because I'm in the bottom corner, I'm just going to circle instead of rewriting. I have two solutions once again. Now, what I would want you to notice is, boy, the second and the third one for sure, if not the first one, look a lot like something that's been factored, which brings up our second item, how to solve by factoring. Now, what I want you to remember is, if you're able to solve by factoring, if you're able to factor in the first place, then what you're going to find that you can do is take an equation, in this case 0 equals x squared plus 4x plus 3, and you're able to factor this part of it. You're going to factor it with a 2x2 grid, and if you need to pause and think about how to do that, you can do so. I'll remind you that you're looking for numbers that multiply to give you a times c, and they add up to give you b. So in this case, I have a 3 and a 4. I want to come up with 3x in this spot and a 1x in this spot. I'm going to factor out my GCF. I'm going to then fill in the top, and I'm going to fill in the side, and now I have a factored equation. Now all of a sudden this one looks exactly like that stuff on the previous slide. So I'm going to switch my colors up so they stay consistent. I'm going to do x plus 1 equals 0, or x plus 3 equals 0. You could imagine solving those two things, and I hope you could understand why x equals, in this problem, -1 or -3. That would be your answer. If the problem gets a little as far as factoring goes, it doesn't make it any harder. Multiplication is still just whatever a times c is, and in this case a is 2 and c is -5. So I'm going to get -10, and I need to add up to get -9. So I'm going to think about, let's see, I need to get 2x squared here. I need to get a -5. I need two numbers that add to get -9 but multiply to get -10. I like a -10 and a +1. I think that's going to give me what I need. So -10x, +1x. I'm a little bit out of space, so I'm going to do the best I can to squeeze this in. I'm going to have 2x on the outside and an x, and a -5, and a +1. So I'm going to have, instead of 2x squared minus 9x minus 5, I have 2x plus 1, and I have x minus 5. And once again, if 2x plus 1 equals 0, or x minus 5 equals 0, I can solve each of those. It's going to take a little bit more work, and I'm going to get -1/2 for the first one. The second one I'm going to get +5, and those are my two solutions. So hopefully this short video has helped you to solve quadratics. Once again, this lesson was from May 30th. It was a Friday, and if you were absent, this might be a good video to help you out. Good luck.